All right, for example 4, you'll notice we have these two lines that look to be parallel. Okay, we cannot assume parallel lines. We have to be told they are. So they look like they're parallel, but maybe they are, maybe they aren't. We have this other line that cuts through them, this slanted line. It creates these angles 1, 2, and 3 that are going to be the angles in the problem. There's also angle 4, 5, 6, 7, and 8, but if they're not showing up, we probably don't need them. If we do need them, we can invent them. So if I need an angle 4, I can just throw an angle 4 where I need it. All right. We're given that angle 1 is congruent to angle 2, or sorry, equal to angle 2. Measure of angle 1 and angle 2 are equal to each other. So I mark it that way. I get that angle 1 is 105 degrees. We need to prove that angle 3 is equal to 75 degrees. Now, I did say we cannot assume parallel lines, but we can assume a line. If I see a line that looks like a line, it's a line. So this is a horizontal line here, this is a horizontal line here, right? So think about the thoughts here. We know angle 1 and angle 2 are equal to each other. We know angle 1 is 105, so how big is angle 2? 105. We weren't told that, but in essence we were. This is 105, we can do substitution, right? Angle 1 equals 105, angle 1 equals 2, so 105 and 2 are the same by substitution. So again, I'm looking at this, that's a substitution. Two things equal to the same thing. Okay, so 2 is 105. What do we know about angle 2 and 3?
180.
Because they form a line, and a line has 180 degrees in it, right? So 180 degrees in a straight line, that happens frequently. All right, so I know that angle 2 and angle 3add up to 180. I know angle 2 is 105 because angle 2 equals angle 1. And then 105 plus angle 3 is equal to 180. Subtract 105, we're going to get angle 3 equals 75, right? So it's just kind of like you're working out the problem and you're telling them reasons why as you're doing it. Okay, this is another, it's not proving so much a theorem, but this is a lot of times you can do a mathematical problem that has a sequence of steps and there's a reason for each step you do. Okay, and as we get to higher mathematics, this is a little exercise you can do with your brain. As you state things that you know to be true, you give a reason why that is true. So I'm going to have that discussion in my Algebra 2 class today. A lot of them are struggling with multi-step problems, and they're not asking themselves why they did anything. They're just like writing down stuff. They saw me do +4 in class, they can do +4 all the time, but it's not always +4, that kind of stuff. So being able to answer the reason why you do things, it helps you to understand a multi-step problem. So that's what's going on here. So we do have a statement reason proof set up here, so let me go ahead and set up my statements and reasons here. Statements. Reasons. Okay, what's the first thing I want to write down on my paragraph, on my proof here? The given information. I always start with given. Okay, it's just a free step. Measure of angle 1 equals measure of angle 2, and measure of angle 1 equals 105 degrees. Given. If nothing else, if you write that much on your paper when it's come time to take a quiz or a test, you're going to get some points for writing down the given information. All right, so part of the answer is sitting right there in front of you. You just got to write it down. Okay. Now, we've already established through our thought process before we started writing this proof that, angle 1. We have measure of angle 2 equal to something and 105 degrees equal to the same thing. So we have two things equal to the same thing. Again, that's something you need to look for all the time. If you have multiple equations, do we have multiple things equal to the same thing? So angle 2 is equal to angle 1, and 105 is equal to angle 1. Both these things equal the same thing, so I know that measure of angle 2 equals 105 degrees by substitution. That tells me how big angle 2 is. I'm trying to figure out how big angle 3 is. So now I'm looking for a relationship between angle 2 and angle 3. We've already established 2 and 3 make a straight line. We know that angle 2 and angle 3 have to add up to 180 because of that, right? So I know that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees because there are 180 degrees in a straight line. If we were all professional mathematicians working for some company trying to prove high-level stuff, officially you'd have to establish the 2 and 3 first form a linear pair, and the 2 angles that form a linear pair out of 180. I'm fine with 180 degrees in a straight line for the level we're at, for freshmen and a sophomore in geometry in high school. So if you have the understanding that a straight line has 180 degrees and the angles making the straight line out of 180, I'm fine with not going through the whole linear pair exercise there. All right. So now, most of the time we've been doing substitution so far, it's looked like this up here, right? We have something equals the thing and something equals the same thing, so we put them equal to each other. Another substitution idea, where substitution the reason, is right here happening in front of us. Let me use my black marker. All right. I know angle 2 equals 105 degrees, and angle 2 lives inside this equation. Okay. So it's not 2 things equal to the same thing, but these have the same value. I'm going to take this out. I'm going to put 105 in. That's another substitution idea. All right, so substitution could be the whole 2 things equal the same thing, so they equal each other, or I want to take something out and replace with something else. As long as I know that equals something that's legal, and that's a substitution. So I'm going to say 105 degrees plus measure of angle 3 is equal to 180 by substitution. The other thing I want to point out to you here is that happens a lot in proofs where the same reason gets used multiple times. Okay, sometimes people consider a proof to be kind of like a matching exercise on a test. Once you use an answer, it's gone. Well, if you need to use the same reason multiple times, feel free to use that reason anytime you want to. All mathematical reasons are always available at all times. And finally, if 105 plus 3 is equal to 180, we subtract 105 from both sides, right? That's an actual numerical value as opposed to some abstract angle 2 that we did last problem. But if we subtract 105 from both sides, we have an equation. If you have an equation, then you may subtract the same amount from both sides. That's the subtraction property of equality every time. So my final step here is to write that fact down. If I subtract 105 from the left, I'm going to be left with measure of angle 3. Subtract 105 from the right, I get 75. And that's by the subtraction property of equality. Feel free to abbreviate to the extent I can understand what your abbreviation means. Prop of ec, property of equality, that means the same. So you can abbreviate to a little bit there if you want to. All right, and there's the proof figured out, right? We start with the given, everything logically through until we end up with what we're trying to prove as the very last statement, and everything's been given a reason. That's what a good proof looks like. So think through it. Write it down, justify everything you do over here with the law of detachment. If 2 things equal the same thing, then they equal each other. Well, here 2 things equal the same thing, therefore they equal each other. So the conclusion is, or the hypothesis met, the conclusion is wrong. Okay? If there's a straight line, then there's 180 degrees in it. There's a straight line, hypothesis met, you add up to 180. Okay? If A equals B, then A can be replaced by B. That's the substitution rule also. 2 things equal each other, or different things equal each other. If something equals something, you replace it. So angle 2 equals 105, I can replace it. If you have an equation, you may subtract the same amount from both sides. I have an equation, hypothesis met, I can subtract 105 from both sides. So every one of those is an if-then statement over here. The hypothesis has been met here, so we draw the conclusion there, stating the reason why right there. So that's every step in a proof is going to be a law of detachment scenario. This is the if-then, this is the hypothesis met, this is the conclusion drawn. You go through with that thought process, you guys understood law of detachment pretty well based on the last quiz. You guys should be in good shape for doing this, as long as you know your if-then statements, which that's where we're lacking right now for this, right? Knowing the if-then statements. So one of these skills that you're going to develop this year is you're going to learn all those if-then statements. Just by doing these proofs, you have to keep on looking back at them. They get stuck in your brain. You can't help it.